doing here today is to explore some of the technology that we identified in one of our recent hackathons that was in Austin, Texas.
Colonel Richardson came into the classroom and said, hey, there's this opportunity down in Austin. It's a hackathon where there's a competition to go and solve some of our nation's toughest problems with small UASs. And I said, oh my gosh, this is perfect. I need to get Todd involved in this because he's got this piece of equipment that would be perfect for acoustic detections of drones. So I reached out to him. He said, yeah, I'll join the team. And so we went down there to Austin. We didn't know quite what to expect, but we were able to form a collaborative team with some of the local industry partners down there in the Austin area.
We won the event, so with that came a $15,000 contract through Army Future Command to continue to develop our project.
The heart of this concept that we presented, which is an acoustic detection capability, is based on an actual prototypes that can be effectively used in the field.
MEMS is micro electromechanical system, and this one it's about the size of your fingernail.
It's essentially a micro antenna tuned to a particular frequency that it can pick up. And these are tuned specifically to the frequencies for the different drone families.
And so by looking at that very specific frequency, it's not listening to all those other distracting noises. So broadband microphones work on the range of maybe 20 to 100 meters. The initial results in the lab have shown that this could be potentially 1,000 times greater.
If we can acoustically or in some other way detect those drones that are coming in early enough and get an idea of maybe which direction and which heading they're coming in from, then we can mitigate some of that threat.
The recent attack on the Venezuelan president, where a small UAS system potentially was an assassination plot, certainly raised the awareness of the challenges that UAS systems pose, both in the civilian arena, just on the streets.
Border Patrol officers can use this while they're looking for maybe drug smugglers going across the border using drones. Can we have security teams using this to defend sports venues, let's say a football stadium, something like that?
And also in military environments where that conflict puts soldiers at risk.
There's plenty of applications where we can use this technology, and by introducing it with the commercial side, it gives a larger scale, and it makes it then in the end cheaper for the military, but it also drives that innovation because in the commercial side they're going to keep making this thing better.
Even if drones didn't engage you with a threat, they weren't loaded with explosives, they weren't loaded with some sort of toxin material, the very fact that they could collect information on you, they fly over the head, they cause the soldier to become distracted from his core mission, which might be to engage somebody or to find someone or to just move. That's really the threat, and so if we figure out ways to respond to that threat, that's good for us.
What if we could put this on every single soldier? What if we could create a network across an entire force with these small systems that are put on each individual person to help us identify these drones in a faster way, in a cheaper way, and a solution that could be scaled across the force?
I think these are very exciting times because this is becoming more common across all services, is how do you work with industry and academics and the soldiers and say, how do you mesh them all together?
The success of the hackathon represented the value proposition that career military professionals, so officers and NCOs that are sent to study at an institution like Naval Postgraduate School.
It reflects really well on NPS as a research institution. That's primarily what we're here for. It's to give graduate studies for the military and make students go back to the force more lethal and ready to solve our nation's problems. But it also highlights a really interesting part, and that is the collaboration across the different departments within campus.
This is a great group, and we're all open to constructive criticism and understandings of way forward, and we definitely have the experience level, I think, to take this out of the field experimentation phase and actually put it into actual field-ready product.
One of the biggest things of this event, being here at Camp Roberts, is that it was an opportunity to bring some folks from Army's Future Command out. Because it's their newest command, it was a chance for them to see what the Naval Postgraduate School can offer. And so in the future, as they're working on innovative designs in order to solve their problems, they keep in mind that the Naval Postgraduate School is a great source of people and a great source of talent that they can come out and tap into in order to solve their problems.